This video goes over the properties of logarithms. I'm going to use the properties on the first two slides to evaluate the expressions. So the first one here is log base 4 of 320 minus log base 4 of 5. I notice that these have the same base and that I am subtracting. So I can bring together the arguments by dividing them. So I get log base 4 of 64. Once I do that, I can now use the procedure that I did yesterday, and I'm going to set this equal to y. And then I'm going to rewrite it as an exponential expression to figure out what the value of that expression is. I know that the exponent 3 satisfies that equation, so that must mean that my log base 4 of 64 is equal to 3. In the next one, I notice that this piece right here is the same, so log base 8 of 2. And so that means that I can actually add these together the same way I would add the expression 5a plus 1a. So this actually gives me 6 log base 8 of 2. And then I'm going to evaluate that expression just by focusing on this piece. So I'm going to change log 8 base 2 into exponential form. So 8 to the y equals 2. I notice that that number is getting smaller, so my exponent is going to be a fraction. And I also know that 2 cubed is 8, so that means that y has to equal 1/3. So now when I go to evaluate my expression, I've got 6 times 1/3, which is just equal to 2. In the next one here, I've got log base 3 of a fraction, and I've got a couple options here. One is that I could split them up into log base 3 of 27, take away log base 3 of 81. Now I know that log base 3 of 27, so I'm asking myself what exponent would I raise 3 to get to 27? The answer is 3. In the second piece, I'm looking at log base 3, and I'm saying what exponent would I raise 3 to get 81? That would be 4, which means my answer is -1. I can also set this equal to y as is. And I can say, okay, 3 to what exponent gives me 27 over 81. I notice that I can reduce this by dividing by 27 to get 1/3. And that also tells me that y equals -1. So those are equivalent expressions. All right, let's take a look at D. So we've got our bases are the same and we are subtracting. That means we can divide the arguments of the logarithm. So I've got 48 divided by 3/2. Remembering your fraction work, that means we keep, change, and flip. So I've got 48 times 2/3. I am going to reduce this first so that it gets a little bit smaller for me. 48 divided by 3 is 16. So that leaves me with log base 2 of 32. I'm going to change this into exponential form to be able to evaluate this. So 2 to the exponent y equals 32. And I think we had this expression yesterday. I know that y has to equal 5, and that means that the answer or the value of my logarithm is equal to 5. Okay. On the next one, here I am trying to solve, so I'm looking for my answer for x. And this is a method, you might have seen it in grade 11, you might not have. It works really well if the answer is exact, like we've been doing so far. If it's not, then we have to use a different method because guess and check is going to take us too long. And that method that we use is we apply the same operation to both sides and we take the log of both sides. When I do that, that allows me to bring the exponent down in front. That is one of my properties of logs. And then log 5 is just a number, so I can divide both sides by everything except for the x to be able to solve my equation. So those cancel on this side and the 2's. I'm left with this, which is just a number, and I can put that all into my calculator. And you should get 0.6045. Let's try another one. So I'm going to take the log of both sides. So I'm applying the same operation to both sides, just the same as if I were squaring or multiplying by 2. That is going to let me bring the exponent down. And then I'm going to divide by everything that is not x on the left-hand side. And repeat that on the right-hand side. And I'm going to use my calculator to do that. And I should get an answer of minus 1.0955. Okay. The next one, a little bit different because my exponent is x minus 2. But I'm still going to... I'm going to use my log method here. This one I could do without having to use a calculator. But just to show you that the method works both ways, so I'm going to take the log of both sides. That allows me to bring the exponent down. Then I'm going to divide by everything that's not x. Which gives me an answer of 5. You can get that with or without a calculator in this case. My last step is just going to be to add 2 to each side, which is going to give me x equals 6. Okay, next one is the same, but it is not exact. So 4 to the x minus 3 equals 55. I'm going to take the log of both sides. Then I'm going to bring my exponent down in front. Then I'm going to divide by everything that's not x. Too many equal signs there. So x minus 3. Well, we'll do this all in one step so it fits. So we're going to put that into our calculator. And then we're going to say that x is log 55 over log 4 plus 3, which is going to give me x equals 5.8906. So not a nice number like the last one. Definitely need a calculator for that. Okay, this one's a little bit different because it's got coefficients that are multiplied together. So we're still going to start off the same way. Log of 2 times 4x on the left side and the log of 5 times 3x on the right-hand side. Because I'm multiplying the arguments together, I can separate the logs. I'm going to do the same thing on the right-hand side. And then I'm going to collect like terms. So I'm going to move all the terms with the x onto my left-hand side. So I've got log 4 to the x minus log 3 to the x. And then I've got log 5 minus log 2, which is just a number. I'm going to bring down the exponent here. And that is going to let me factor out the x on the left-hand side. And then log 4 minus log 3 is just a number. So I can divide everything on the left side by log 4 minus log 3. Oops. Which is going to give me x equals 3.1851. I could consolidate both of those sides by dividing the argument, but I know that I'm going to use my calculator to evaluate it because they're not exact, so I have just left it as log 5 minus log 2. So one more example on this slide. We're going to take the log of both sides, same as before. And then I'm going to bring my exponent down in front, so 3x plus 1 log 10. Log 10 is actually equal to 1. So that's a way that we can shorten it if we need to. We don't actually have to do this step. Dividing by 1 just leaves us with our original question. So we've got 3x plus 1 equals log of 105 over log 10. And then we're going to take away 1 from the right-hand side and divide by 3. So our x is equal to log of 105 over log 10, which is 1. We're going to take away 1, and then we're going to divide the whole thing by 3, and you should get 0.3404 on your calculator. Okay, let's do one more series of examples. We're going to use the properties of logarithms to split up the expressions here. So the first thing that I'm going to do in this one is I'm going to change my radical to a fraction. And then I'm going to bring my exponent down in front. X cubed, y to the 8. Now I notice that my arguments are being multiplied together. So I can split them up by adding the logarithms. This isn't the only way to approach this question. It's sort of like simplifying things with exponent laws. There's kind of multiple right ways to get to the same answer. Once I've done this here, now I'm going to bring my exponents down again a second time, and I'm going to distribute in by the 1/4. So I'll do that in 2 steps. So I've got 1/4 times 3 log a of x plus 8 log b of y. And then I'm going to multiply by 1/4. So I've got 3/4 log base a of x plus 2 log base b of y. And now I've effectively separated it into log base a of x and log base a of y. Let's try the next one. I'm going to start the same way. I'm going to bring the exponent down in front. And then I'm going to separate, except this time I'm dividing the arguments. So I'm going to subtract the logarithms. Got log base a of root x to the 5. Take away log base a of y to the 4. On my next step, I'm going to change my fractions now to an exponent, or my radicals to an exponent. So I've got x to the 5 over 2. And then my second one doesn't change. Now I'm going to bring the exponents down in front. And then I'm going to multiply through. So I've got 5 over 6 log base a of x minus 4 over 3 log base a of y. Okay, the last two, we are evaluating expressions, and so we can actually do this in two ways. We can separate them out, or we can combine them all together. So let's take a look at combining them all together to show you how those properties work. So I could evaluate each of these separately, but that's going to take me 3 steps and then another step to put together. Instead, I'm going to notice that I'm adding all of these logs. So that means that I can multiply all of these arguments together times 1 over 9. Okay, so now I'm going to simplify this. Let's see, I don't think I need a calculator here, but we'll see. So 81 divided by 9 would be 9. And so I've got log base 3 of 27 times 9. And I would probably separate this. I would go log base 3. I would say 27 is 3 cubed. And I know that 9 is 3 squared. So I would write this as log base 3 of 3 to the 5. And then I'm going to bring down my exponent. So I get 5 log 3 of 3. And I know that any base where the argument is the same is just equal to 1. So I can say this is equal to 5 times 1, which is just 5. You could also evaluate it separately and get the same answer. Okay, let's try this one here. So before I can add and subtract the arguments of the logarithms, I need to get rid of any coefficients that are in front. So I'm going to bring that 1 or that 3 up. So I've got 4 cubed is my first argument, 2 is my second argument, and then 4 is my third. The first two are adding, so I'm going to multiply those arguments together. And the third one is being subtracted, so I'm going to divide that, or I'm going to put that on the denominator. This is going to leave me with 4 squared times 2, which is log of 32. And this is one that I could evaluate on my calculator because that's not a nice base. And I should get 1.5051. Hopefully that helps to understand some of the steps in the properties of logarithms. We'll be practicing this again tomorrow. Good luck.